Hello and welcome to Naughty Daddy's Guide to Computing, from Maths to Minecraft. In this video we're actually going to be subtracting numbers rather than adding them. How do we subtract numbers? Well, in decimal, let's take the number 27 minus 4 equals 23. Dead easy. Okay, nice if you're a mathematician working with a blackboard. What if you're a computer? How do you subtract the 4? Well, one way is to have a completely different circuit pathways to teach a computer how to subtract. And some of the more complicated computers do actually do that. We could take a binary value and subtract another binary value, and we get as simple as that. Another way, and a cheaper way, and the way that's preferred in computer architecture, is when we subtract two numbers, let's say again 27 from 4, instead of subtracting 4, we add negative 4. So adding negative 4 to 27 still comes out to 23. Adding a negative value is the same as subtracting. Okay, so how do we create a negative number in binary? Well, if you'll recall, in all the other videos I've always gone one too far with my column headings. So if I wanted to create the number 8, for example, I would go 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. That's all we need, surely. That's just 1 0 0 0. But I habitually go one more and go 2 to the power 4 is 16, and then I express 8 as 0 1 0 0 0. This is because by convention binary numbers starting with a 0 are always positive, and binary numbers starting with a 1 are always negative. And when I said 2 to the power 4 is 16, if that's the length of my word, if that's the highest number I'm going to 2 to the power 4 in this case is not. It's actually negative 16, and this should be negative 2 to the power 4. So the leftmost bit in computer architecture is reserved for a negative value, and then all the other bits are positive and they're added to that negative value. So what does this mean for negative binary numbers? It means if we take all of the positive numbers and we add 1 to it, we're going to end up with a 0 here, carry the 1, 0 here, carry the 1, 0 here, carry the 1, 0 here, carry the 1. And then that 1 overflows into the negative number. So you get from here, which is 8 plus 4 plus 2 plus 1 is 15. You add 1, you end up with negative 16. Which is ridiculous. So when you're programming, you need to be aware that that's what the computer architecture will do. So you need to know that if you're adding two positive numbers together and your computer says the result is negative, you need to say that is an overflow error, and that's where you print your error. So we can't have 15 plus 1 is minus 16. But that does tell us something. If you have that 1 there, and all of these are all 1s, you've basically got minus 16 plus 15, which is minus 1. So you take a binary number, it doesn't matter how many ones you've got. If you've got millions of ones, you know if it's all the ones, then that number is -1. Okay, let's just count in binary. Let's go up to, say, I think 8 should be far enough. So let's say 4. Oh, I can't write. 5, 6, 7, 8. Okay, so these are the positives and these are the negatives. Okay, so what's the word length we're going to want for 8? Well, we don't want to go higher than 16, and 16. Okay, so we need a 5-bit word, don't we? Okay, so that's 1, 2, 3, 4 and a 1, and then 2, that's going to be 0, 0, 0, 1, 0. We're adding 1, so that 1 becomes a 0 and we carry 1 into the next column. And then this one is just 0, 0, 0, 1, 1. And then this one will be 0, 0, 1, 0, 0. And we add another 1, so that becomes 0, 0, 1, 0, 1. And this becomes 0, 0, 1, 1, 0. And then 0, 0, 1, 1, 1. And of course 8 is 0, 1 in the 8s, and 0, 0, 0. Okay, so now if we want to negate these numbers, how do we negate them? Well, we already know -1 is all the ones. 1, 1, 3, 4, 5. And then if we're going to add 1, if we're going to subtract 1 from this, we've just got to take a 1 off. So that's 1, 1, 1, 1, 0. So that will become -2. And if we take 1 off again, 1, 1, 1. So we borrow 1 from this column, and then this becomes a 1. So, and that's -3. Well, how are we getting from 00011 to 11101? Well, the way to do it, we call it taking the 2's complement. And the way to take the 2's complement is to first turn all the zeros into 1s and then add 1. So if that 0 becomes a 1, that 0 becomes a 1, that 0 becomes a 1, that 1 becomes a 0, that 1 becomes a 0, and then when we add 1, the 0 becomes a 1 again. So let's do that with the 4. So that's a 0, so it becomes a 1. That's a 0, so it becomes a 1. That's a 1, so it becomes a 0. That's a 0, so it becomes a 1. And that's a 0, so it becomes a 1. And then we have to add 1, so these 1s become 0s and a 1 goes over into this column. So that 0 becomes a 1 and these two 1s become 0s. So that's a 1, 0, 0. And we could have arrived at it the way we did before. If we just take a 1 off that, we end up with 1, 1, 1, 0, 0. So that becomes -4 or -4. So for the -5, what we're doing here, we're turning that 0 into a 1, that 0 into a 1, that 1 into a 0, that 0 into a 1, and that 1 into a 0, but then we have to add 1, so it becomes a 1, and that then becomes our -5. Let's do the same with the 6. So that's 0 becomes a 1, 0 becomes a 1, 1 becomes a 0, 1 becomes a 0, 0 becomes a 1, and then we have to add 1, so that 0, 1 becomes a 1, 0. tidy up that a little bit if I can without making a mess. Okay, so for 7, what are we doing? So that 0 becomes a 1, that 0 becomes a 1, that 1 becomes a 0, that 1 becomes a 0, and that 1 becomes a 0. That's minus 6. This is minus 7. So you can see how we're actually taking 1 away each time. So here number 8 is easy. So that becomes a 1, that becomes a 0. These are all 1s. We have to add 1. So all these 1s go back to 0s. And then this becomes a 1. Oh dear, I blasphemed. I wrote a 2 in binary. We all know there's no such thing as 2. Okay, so that's a 1. And then these are all 0s. And I've gone wrong because that's minus 8. So where did I go wrong there? That's a what? That becomes a 1. That becomes a 1. These are all 0s. And I forgot to add the 1. And that's why that's wrong. Okay, good job I spotted that. Okay, so you can see here we're just counting down. Right, so that's how we get our negative numbers. Let's just double check that this is right. So we're saying this is minus 7. So let's try. That is going to be 1 plus, there's no 2s, there's no 4s, that's an 8. 1 plus 8 is 9. And then this is 16, but it's got to be negative 16. So it's negative 16 plus 9. And let's see what that gives us. 16 negative plus 9 equals negative 7. So that is correct. Okay. I hope you see how we've managed to get our negative numbers. In the next video we're going to actually try some examples of subtracting numbers in binary. I'll see you in the next video.